So before we start, any question about what we cover in the last class? So just say two things, just to recall. So we will have a quiz, quiz on Thursday, this Thursday, and the test of this or exam of this class will be on November 26th. I will put that on the blackboard later today. I forgot to put it in, but I'll put it on. And I also put on the project that you're going to do today. We can talk about that on talk a little bit about after the quiz on Thursday. The first day with the quiz will be on the hypothesis testing. Okay. If there are no further question, then is there no question? No question, then we start the class. No, the quiz will be, let me write that down. The quiz will be on November 26th. It's on Thursday at night, 7:30 to 9:30. The text will be, I'll put it on the, because the time zone difference, so we put it on 7:30 p.m. to 9:30 p.m. Open book, but I'll put it on. But any other question besides the timing? Any question? Let me know if any. Yes, you need to I will put it on, we will be put on the cam so that I can see whether you are not cheating or not. That's it. And the and then will be I upload the PDF for the exam question, then you just do it and then take it. That day, I think we will have, I think my tentative plan is to go over Q&A, I guess, or go over some questions. That would be something. I mean, you don't have, there's no office, I don't think we have class. Yeah, I think we finish everything by, as in the schedule, right? I think we will finish everything on the 19th. Yeah, so it should be done by then. Everything will be done by the week before. Yeah, you have the mic and the cam both on, yes. Because I worry about the for the fairness. Yeah, in case you cannot attend, then you have to let me know. We can schedule the makeup for you, but only if you have legitimate reason to absent from that. Just for fairness. And you can use it's open book, so. Any question? Yeah, you attend, then you check IDs. I think we will say you arrive like 10 to 15 minutes earlier than check the ID, yes. Or you can just, we can do it like normal exam. You just come in and then TA and I will try to check as you send me. I think we'll give you more detail on those. Probably you check in a little bit earlier because you don't want to come in at the exact moment, right? Yes, thanks for reminding me. Yeah, I think you have to come a little bit earlier, maybe 10 to 15 minutes earlier to check. You do have class? I don't think you have, right? In that night, I don't think they have class. Is there any class? Is it class from CHK or what? So I mean, you either you take this or you take the makeup one. Because we have some other student also other time zone, so I have to put in at night. I cannot put in a class. Is that okay? Send me the proof of you if you try to take the alternative one to prove you are not your absence. Is that okay? We arrange we arrange a makeup for you if you have the resolution to absent from that. Is that okay? Any further question? If no further question, then we will continue. So hypothesis testing. Here we have just to recall, we have one sample and then we have two sample, but let's quickly do show you the whiteboard and see everything there. So as hypothesis testing, okay, so we have one sample and you have two sample. Okay, I just review because we'll be doing we're doing quiz next class anyway. So look at the mean. You can also look at the proportion. Okay, and for proportion, always use z-tags, right? For the mean, whether you know sigma square or you don't. Okay, and this is also C test, and this is T test, right? And to sample, you have actually more than you have three things. You can look at the mean, you can look at proportion, and one additional thing, look at the variance. Okay, you can compare variance of two sample. And for mean, we always focus on the case we don't know. We don't know sigma square, so we use t-test. And there are three types of t-test common, right? One is they have equal sigma square or unequal sigma square, or they're paired. okay? And the variance will be the proportion. We also use C test, okay? And the variance use F test, okay? So today, what we are covering is we'll cover this one, and this one, okay? We have covered all this, okay? So you have a quiz of all of them on first day on all this. Okay. I guess we should start. If there's no question, this overview of what we're doing, and just a very brief review of the two sample, right? So here we have when the equal variance, okay? So this will be T and degree of freedom is N1 plus N2 minus 2, okay? And this pooled variance follow a little bit funny shape, but I hope that should not be an issue for you, right? This is an estimate for the variance, right? It will be N1 plus N2 minus 2, and S1 squared, N2, N1 plus N2 minus 2, S2 squared, sorry. So this is this pooled variance, okay? And same for the same for when you do the confidence interval estimator, you do the same thing, okay? So, and the unequal variance, okay? You cannot use the pool one, so you directly estimate what actually it is, right? So then the key part is here, this guy, right? This guy will be, as we can see from the example, you're close to this one, but usually not. If they are too different, then may not be the same, but in many cases, this will be not too far away from this one when you used to estimate that. But I think this is covered last time. I just remind the key point here. Just this is a crazy thing. Later you will see there is a function in Excel that directly gives you the answer. So that's what we'll go. Later we cover today t-test. Okay, will give you. You don't need to calculate directly when if you working on data. Okay, then you can skip this part because this will be given directly. But let's talk about this later. When we finish all the slide, then we can have some time to cover how Excel calculation. Okay, so this is what we covered last class until here. So any question before we start? Okay, if no, then we are going to talk about this. Okay, so what is this pair difference for? So usually for drug test, okay, or for experiment, this is very commonly used, okay, or you can call before after comparison, okay. So what it is what you're doing here is you have some subject or some people or some observation. You have before, it's an observation, okay. After you apply the experiment or apply the drug, you have after, okay. And this will be applying to here, okay, before and after. And that's you will see how the difference, right? So So you want to compare whether they, after the drug applied, there is any difference between the two, right? If the drug is useful, right, you actually measure some metrics, maybe whether number of germs in your body, right, you reduce, right? Or some cosmetics, whether apply the cosmetic, your skin will become smoother, right? That's the case. Or some product that makes you slim, look at the BMI before and BMI after, right? You see the difference, right? And do note that when you have one set of observation and the other set of observation, right? And each observation you have before and after, right? So in that case, N1 and N2, the two sample should have the same size. So N1 equal to N2 equal to N. Okay, so there's only one sample. Okay, but you have actually measuring with before and after. Okay, so you want to see whether there's an effect for some treatment here. Okay, and so that is you can say the treatment effect, you can see. Okay, and the observation here, usually you call the first guy is x1. Okay, before is 1. Okay, after you see it is x1 2. Okay, the second observation, second subject x2 1, after it is x2 2. Okay, and they are linked in this way, and you care about the difference. Okay, whether the difference makes sense or not. Okay, either you care 1 1 minus 1 2 or 1 1 2 minus 1 1, doesn't make a difference when you do a two-sided one and two-sided test, and whether you subtract each other doesn't make a difference. But if you care about say, if you care about the drug, right, you should say depends on what you're measuring, you would put one-sided, right, because you want the drug to be effective, right? So one-sided is more appropriate assumption than otherwise. Okay, so here, although a two sample and they're related, and you assume the difference, okay, have a normal distribution. Okay, here you invoke the idea why the difference follow the normal. It's just central limit theorem, right? Assume that many processes affecting the difference, but at the end of the day, right, if you follow this assumption, assume this is 0, right? The difference, it will follow the mean 0 with some sigma square. Okay. Okay. So and of course, the average of them will follow over n, right? And that's why use T, you'll be using the SD, okay, so that's sample 1, okay, to proxy the sigma, so use T instead. Okay, so basically just the difference follow a normal distribution, and because we don't know sigma, so we use the sample standard deviation or sample variance to complete the calculation. This is exactly the one sample case. Okay, so that's why you will see I -1 here, not -2, right? This is not Tn1 plus n2 minus 2. Okay, if that's the case, it will be T2n minus 2, right? So this is not this case because we only have n random variable here. The difference is the random variable. Okay, any question? So this will be the SD, okay? And the critical value will be the same, just the same thing, right? So so nothing deep here. So this is also confidence interval. It's also the same thing and as one sample, right? This is when you have one sample, unknown mean, then unknown variance is just this guy. Okay. So here, let's see that. So we have medical tests with control group and treatment group. Okay. Let's make this 1. This is 2. Okay. And the sample size of 16. Okay. difference, the mean difference is 1, and next is 2. Okay. So let's draw a diagram. Okay. We have x1 bar minus x2 bar, which is d bar. Okay. So the null set at the same. So the d bar should have a normal distribution. Here have a 0. Okay. And sigma square over n, we didn't know, no idea. Okay. So that's why we use t, which is t here. We have t n minus 1. Okay. And again, this is 0 here. Okay. And what we have is d1 is 1, so it's here 1. Okay. But the sample variance is 2. Okay. So let's convert this to here first. Okay. And what we want to know is this area, right? And the symmetric side, this area, okay? This is 1 here, then this means it's -1 here, right? And we want to see this, the area of this is less than or bigger than r over 2, right? It's two-side test, so this is what we care, right? And as we said, we don't know sigma, so we convert to t. And what's 1 represent t here, right, is 1 minus 0. So do note that there's a typo in your handout, so it's not 2, it's just a 0, because we hypothesize this is 0 mean. So there's this guy minus 0, and divided by this over n, so it's 2 over root n, give you 2. Okay, so here is 2. Okay, so we only care about 2 here and -2 here, right? We want to see the total of this area is bigger than alpha or not, right? Because two-tailed test. So is t, if here, actually this is 15, right? T15. So we want to check this area, right? Area will be t, this, right? 2, 15, true. Okay. And remember, this gives you the left-hand side, so it's 1 minus. Okay. And then you want both sides, the p-value is 2 times. Okay, so this gives you, turn out this number is 6%. So it's greater than 5%, which said that you cannot reject, right? For the 5%. Of course, if you use 10%, then you will reject, but for the 5%, you don't. Okay. And now the alternative way, right, look at the 5% thing, right? Look at maybe this other color, orange color. You want to see this orange color thing. This is exactly alpha over 2. Okay. So what this number is, right? This, if you don't write any, someone asked me whether alpha is 5, 10, or 1%. If it's not given, the standard is just 5%. But it should be given to you. You'll be given what is the what is significant. Yeah, unless you are told, you use 5. Is that okay? Don't know. Yeah. So over 2 here. And how to find this number, right? This number is just t inward, okay, 0.025, 15, okay. We give you the negative 2.1314, or this is 2.1314. So that's more extreme, okay. So that means that 2 is not fall within the rejection region, so you can't reject. So one way or the other. Is that okay? Any question? If there's no question, then we will be going to next. Okay, this is a proof. As we said, we assume the difference is normal, so that's why everything follows directly. Okay, so now this is the another one. Do note that it's a little bit trickier here, although proportion seems to be usually easier, but this is some tricky thing. Later you will see the tricky part. Okay, so proportion. Okay, the null alternative is whether they're the same and the difference. Okay, and that actually no different from sample mean, right? Because this, okay, so this proportion of 1, right, will follow a normal distribution with pi 1, 1 minus pi 1 over n. Okay, this is what we learned from the previous topic, right? When n pi 1 is bigger than 5 and n times 1 minus pi 1 is also bigger than 5, right? This is it's a good approximation of normal, right? So this is 2 cases. Okay. So what we want to look at is this P1 minus P2, right? Under the null, they're the same, so mean 0. Right, mean 0. And you know the variance, right? The variance will be, because they're independent, right? So it will be just sum of them, right? So the variance should be, this guy will be just, this add this up. So these two add up, right? But we can do better because of the fact that you say they're the same, right? So under the null, they're the same. So the variance, right, will be equal to this variance of, maybe I should put more precise. So the variance of this whereas this, right, will be pi 1 minus pi over n, okay, because when they are the same, equal to pi, okay, plus pi n2, so it can be written as pi times 1 minus pi n1 plus 1 over n2. So this is exactly here, okay? So what does it gain when we write in this way? It's because we can estimate pi directly, right? Because pi is the sample proportion, right? So we can estimate pi as x1 plus x2 over n1 plus n2. So this is the tricky part here. Okay, this is a tricky part in the proportion is this guy. So this is the first tricky part. You estimate this by looking at the total proportion, combine the sample and over the proportion. Now, because they're the same, you can just combine, right? Because you can set the two populations have the same proportion and you just combine them and do the estimated total proportion. Okay, so that's the idea. You can do it because under the null hypothesis. Okay. So if you are not doing the hypothesis testing, you cannot do this trick. Okay, this trick is only work when you do it. Otherwise, you have to put back the 1 here. Okay, if you don't have this assumption, put the 1 and 2 here. You estimate pi 1 and pi 2 separately, and that would be the variance will be larger. Okay, if you do this, the variance smaller, it's easier to reject. So it's better. The test will be even better. Otherwise, anyway, I hope that's okay. So you see the example, then you hopefully will be getting. So as I said, this is the key trick here. And the other trick here is, as I said, when you do converter interval estimate, you cannot replace it. Okay, you have to estimate pi 1 and pi 2 separately because we no longer have they're the same. So when you do the CI, it's different from the hypothesis testing. So this is the main key difference. You have to be careful. Okay. Any question? Because this is very important. I want to make sure that you okay with that. Okay. If there's no further question, then we go to example. Okay. The example here we have is we have the simple random sample 50 and sample portion is 0.6. So N1 is 50. Okay. And P1 is 0.6. Okay. So you can infer from here how many people are is 30 people, which belong, you say yes, right? It's binary data, right? Remember the binary data. So our 50 people, 30 people say yes, okay? This proportion you care. And here you have this coming from N1 times P1, right? Because P1 is X1 over N1. And N2 will be 40, okay? And sample proportion is 0.7. So P2 is 0.7. So that's X2 is 28. Okay, so that's just the data you have. Okay, data. And do note that's binary data, right? So how you get 30 here is in the data you have a bunch of 10, 10, 10, 10, and up there are 50 of them, and there are 30 of them are 1. Okay, so that is the data, binary data. Okay, just to make sure that you understand what the data you have. And given this, right, so you are trying to do the hypothesis testing. You're asking to do the test whether the same and they're different. Okay, so just to recall, we will be first, we are estimating the pooled one first, right? Pooled one is N1 plus N2, X1 plus X2, okay? So that means 30 plus 28 over 50 plus 40, okay? So the numerator is 58, the denominator is 90. Is that okay for the pooled one? So this is the also the pooled proportion, or you can say this is the if you this is equal to pi, okay? This is the sample counterpart of this, right? The sample proportion, right? Under the assumption that they have the same, okay? You can do this because you say they're the same, okay? Otherwise, you cannot do this. Okay? If that's okay, then we go to the next slide. Remember, this is 58 over 90. Okay. So these are the numbers here. Now, let's clean this and we go to the next slide. Okay? Just to recall the number here, N1 is right here a little bit. N1 is 50, P1 is 0.6, N2 is 40, P2 is 0.7, and we just calculate from here, P bar is 58 over 90, right? Then 1 minus P bar will be 32 over 90, okay? So that is P1 minus P2 over P bar times 1 minus P bar times bracket 1 over N1 plus 1 over N2. So that's the formula. And once you calculate this, it's a very small number, okay? So just recall what you should be doing here is this, right? You say the same, so P1 minus P bar, P2, right? We have a 0 here, right? And you figure out this is the data, so this is negative 0.1, right? So you convert it to the C space, right? Z space. This is Z, okay? So this again, this is 0 here, okay? And you look at this, is whoa, it's negative 6, okay? And immediately you know negative 6 is so far away from anything, right? That basically you are almost done, okay? You don't really need to look at it. Basically, this is the probability is almost 0, okay? Why? Because you just look at Excel, right? Look at this number, okay? This is the norm standard S inward, okay? 6, or here it is negative 6, is easier because look at this, right? And you 2 times that because you're doing the 2 tail, okay? So then it's close to 0, right? So it must be less than 5%. So you reject, okay? Or we look at the 2 side again, right? Just repeat a little bit. Look at the 2 side, right? It's alpha over 2, right? Look at alpha over 2, right? So you can look at this number, right? How you get this number, again, let's repeat. This is, oh, sorry, there's typo here. This should be this. Norm S inward, okay, is 0.975, okay, and this gives you the 1.65, and obviously it's much less than negative 6, right? It's right here, right? So it's deep inside the rejection region, so reject at 5%, right? Actually, at any percentage you can put, because it's so small, you can put at any percentage here. Okay. So lastly, you can do confidence interval. Okay, here, put this number Z. Okay, Z alpha over 2. But do note that we use P1, 1 minus P1. Okay, we are not using P bar. Okay, and this is P2 and 1 minus P2. Okay, so that is the difference between the hypothesis testing and confidence interval. Usually they're the same, but in this particular case, they're not the same. So the denominator, you cannot just plug in the denominator here and put it there. It's not going to work, okay? And this one is bigger than the denominator because you make some assumption here, so it's more accurate, so it's smaller. Okay? And is there any question? No? So, very briefly, the proof. Actually, we have said it, right? Because under confidence interval, you don't have the same, so you have to use this one. And if you do hypothesis testing, they assume to the same, so you can just combine together. Actually, this is smaller. Okay, you can actually show this is this one. You've got A, this is B, and B is smaller than A. Okay. If there's no question, let's have a break of 15 minutes and then we will resume. Yes, your question? No? Okay. So I answer question. Someone asked me the question. Someone asked me the question about under the null hypothesis, the same proportion. The meaning is coming from here. So let me share the screen. So the meaning is here they have the same. Sorry, so here is they're the same proportion under the null hypothesis. Okay, so that's why we can say they're equal to some number pi. Okay, we can estimate this pi directly by saying P is equal to x1 plus x2 over n1 plus n2. Okay, we can use this to estimate this. This is much easier because they're just the same proportion. Then you can just combine the two together to estimate. Okay, and if you do confidence interval, you don't have this luxury. So you have to, this one will be much bigger. You have to estimate them separately. Is that okay, Huan Yi? So if you use this is smaller, right? But if you use this one times this is actually bigger. So bigger means you cannot reject it easily. So that's not so good. So another question I have is how to interpret the confidence interval. Okay, so again, let's explain. Say, use this example. Confidence interval. What it said is, okay, what it said is if you repeat this interval estimator, what it means is if you repeat this, okay, say you repeat this 100 times, okay, it means that suppose you use alpha is 90%, 95, right? 95% of them will include what we want to estimate, okay? And 5 of them does not, but we don't know which 5, which means the probability that our interval will include a mu with probability 95%. That is fine, okay? That's probability. But once you have the interval, then it's either in or not, so there's no probability anymore. But instead, we say 95% confident that will be there, but that's what it means. Is that okay, or you need me to understand again? So it's a sample. So not sure, maybe I just. So it means, okay, if you construct so this is the mu is always some value, okay? We don't know where it is, right? But we know if you draw this sample, right, you will have center at the mu, okay? And you actually know it, right? Actually, this, when you get it, you can see, okay, this width, right, will be z alpha 2 sigma over n. Right? So then this will be the ME, right? So this will be mu plus ME, and this is mu minus ME, right? So before you draw, right, this is alpha percent is within here, right? But once you drawn, right, once you drawn, right, so it will be somewhat, maybe you drawn here, you also can draw an ME, right? X bar plus ME, right? And X bar minus ME, right? If you draw many of them, right? And then actually means that 95, say 100 of them, 95% will be within this one, right? That will include this mu, and 5 of them doesn't. Okay, so that is what it means. So that actually means you only draw one. So, but you said only that's why it's a confidence. You don't say probability, because once you draw, that's no longer probability. So, but you believe that if I repeat this many times, 95 of those would include the sample mean, but we don't know which one. So that actually what it means. And someone asked me homework 3. I'm not sure don't know what's the question. Is it homework 3? Which question? Q6. Q6 is 6.6, 8.61. So which part? I don't know which part. Well, you calculate the confidence interval. You want the sample proportion. This is the sample size, right? So that's a standard thing. I think we covered it in this class. If you so you have to answer the question of C and D, right? Then you're asking you, in order to answer question C and D, what you should do. C tells you how many sample size you need, and D how many sample size you need. But in order to answer the both questions, what should you have, right? And you don't want too many, but you want just enough to answer the 2 questions. And Donald, is that clear? Yes. So just to let you know that this is some details of the test will be 26 first day, 7:30 to 9:30. Okay. If you have makeup, will only be allowed it only if you have formal excuse. Okay. Okay, you have applied. you only have, and let me know in advance. Okay, then you can, we'll arrange a makeup for you. Okay. And then log in 10 to 15 minutes, then to check ID. I think I put the Zoom there. And then the Zoom online, and then it's open book style. PDF will be uploaded to Blackboard. And to avoid cheating, you just write on your own A4 paper and either you take photo or you scan it. I think take picture is easiest, just to avoid cheating. Open the mic. I know, at least open your webcam. I think you open the webcam, I guess. But I will ask you to open the mic if I saw your mouth keep talking. Well, because I want you, the question why I don't allow it to be typed, because I worry about you send it out, so that I avoid cheating, because once you type, they can send out the answer. So that's I want to avoid that happening. And also there are a lot of formula, so that's why I don't see it. It's easier to write than type in that sense. Yeah, there any I haven't made the test yet, so that's why I don't know. I cannot answer what kind of question you have, but likely you have, as you said, likely you would have some short question. A lot of type. Yeah, you can use Excel to calculate, but you have to tell me what function you're using. Yeah, exercise you can type, but for the exam, I want you to type, because I don't. If we go to lab, then you can type, but run the iPad. Let me think. Can you run the iPad? Can you send it out? I think. Let me think about whether iPad is allowed, because I worry about sending it out. I think iPad is fine, because I think I think iPad will be fine. If you write iPad should be fine. Can write iPad. I think I can allow that. Okay, can write in iPad. Okay, if you write in iPad is fine. Write on iPad. It's okay. It's okay. As a handwriting, I think it's fine. Then it's not easy to copy. No, homework no need. Homework can type. Homework can type or write. It's not fun with the homework. C table, you don't need C table, right? It's open book. You can use C table or you can just use Excel. Total 6 assignment. Well, we have assignment 3. Actually, the one that you do the peer review is considered part of the last assignment. So there will be 5 assignments. The last assignment with the peer review for your project and also for homework 1. So basically 5 assignment plus 1 assignment. So there will be assignment. You'll be assigned after the hypothesis testing with 1 assignment, and then 1 more assignment for the ANOVA and the regression. Yeah, if rare is fine. If you just skip some step, then you cannot. For the assignment, I think it's fine, but I think for the test, you need to state your I should say that explicitly, right? State Excel formula. Okay, if you use Excel. I think that would be fine. Okay. For the assignment, I think it's fine. But for the next assignment, I think you should, if you use Excel, then you should state the Excel formula. For this assignment, I think it's fine. Any further question? Just to remind you that we only have, because of the time, because this year, everything slowed down because of, we cannot give assignment early. So there will be, you will see I will combine the assignment 5 and 6 to one assignment. So there will be, after today, we finish all the hypothesis testing, then we will have one other assignment, and there's a final assignment, and that's it. No, we don't. I mean, everything is just you just write down the function you use, and that's it. You don't have to attach. I mean, you can attach, but you don't have to. Yeah, you don't have to, because I don't want you to. You don't need to spend time on making nice of the assignment. Just what I mean is, right? Say suppose, let me give example, right? So just like when you, right, when you calculate P, say Z is less than whatever, I mean, whatever value, right? Then you arrive some number, then you can just say this one. Someone asked me how many exam question. I haven't made the exam yet, so don't ask me that question. I don't know. I mean, I'll let you know once I make the exam. At the moment, I don't know. I'll probably make it this week or the next week. Because I also look at the quiz, how we're doing the quiz, I have to adjust. So that's why. But you might be, because this is an elementary class, so you may be expecting more questions than you can handle usually. So then I can differentiate mod exam. Well, as I said, the exam will be, you can look at the style that pass exam in the library. For other section, that will be similar style. Homework is fine. Homework is fine. You don't have to write that down for homework. But for the assignment, I expect you for the next assignment, you try to write that down, because that is the way you should do an exam. But for you don't, it's not necessary, but I suggest you write it down so you know. Is that okay? Yeah, you can use calculator, but yeah, calculator. But because this class is taking Excel, then I suggest you use Excel to do the calculation, right? Because the goal of this class is Excel, right? What known formula for Excel? What's your one? Oh, of course, if you don't use calculator, you can just write down what's X bar minus mu, and this I don't think you need the formula. I think the Excel you use is very simple, right? Just this kind of formula. I don't think this class will have a lot of calculation, right? I don't see. I expect if you use calculator, I think you should use the Excel, because this is what the purpose of this class is. I mean, just to make the grading everything easier to compare. Otherwise, just sorry, but there's some limitation we can do. Okay, any more question? I mean, if no, then we will, okay. If nothing, then we will go to the last part of our slides, okay, which is the F-test. So here, actually the logic is rather simple, okay? We have sample, try to see they have same variance, okay? With sample one, this sample one, this sample two, actually coming from much earlier thing, you have population 1. Okay. Population 1 have some sigma 1 square, and we have other population 2. Okay. We have sigma 2 square, and we are getting some sample from here. Of course, we have sample mean and sample variance. Again, we have sample mean x2 bar and sample variance. Okay. What we are trying to see is are these two the same? Okay, that's what it's asking. Okay, and the natural thing you would imagine is just to say, can we do this? Okay, is it going to follow certain distribution? And turn out this is not easy to do it. Okay, but this one is easy. Okay, so the difference is not easy to do it. It's not, I don't know, but this one turned out to follow F distribution. Okay, with, so this, you have N1 sample, this N2 sample with degree of freedom N1 minus 1, N2 minus 1. Okay, and you can imagine if they're the same, right? Sorry, this is 2. Okay, if they're the same, then this is close to 1, right? The ratio is close to 1, right? The difference is 0, but the ratio is 1. So we expect this S1 square over S2 square should be close to 1, right? But it's no longer this shape, right? It's no longer this shape, unfortunately. Okay, it will be some, depends on the size of N1 and N2, and because of ratio, this is bounded below by 0. Okay, there's nothing below 0, and turn out this shape is something like this, or something like this, or something like that. And there are many shapes. It can be decreasing, can be like a bell shape. So, but the idea is same, right? Normally you expect around 1, right? But you look at both sides, look at alpha over 2 here, alpha over 2 here, okay? And the difficult part is the two sides are not symmetric, okay? So that's why the left-hand side, this is what we call the left-hand side will be F alpha over 2, and the right-hand side will be 1 minus alpha over 2, okay? So you have to check whether what you found, is it within this region or within the rejection region. If in rejection, you reject, right? If outside is not, right? It's around 1, then you don't reject, right? This is very natural. Is that okay? So do note that it's asymmetric, so that's why you look at both sides. You can calculate both sides. Okay, and this is just how to figure out this. Is just later I will do it Excel, but just add inverse, right? And you put alpha over 2 here, and you put n1 and 2 minus 1. Okay, and this is the same. You f dot inward 1 over alpha over 2, n1 minus 1, n2 minus 1, n2 minus 1. Okay, and there's another function in Excel which, if you like to remember, but if you can remember without make your mind too crazy, is you can say right tail and just put alpha over 2, n1 minus 1, n2 minus 1. Okay, so you can just forget about 1 minus. You put right tail. So that is a only thing I want to say. Okay, so let's see the example, then you become more clear what's going on here. Okay, so this is the example. Look at the right tail, but also look at the left tail too. So here, what we have is sample n1, and so it's n1 is 50, and s1 square is 30. Okay, and this N2 is 40, and S2 square is 20, okay? And again, you want to see whether they're the same, just two-tail test, okay? Of course, you can use one tail, everything will be just the same idea, okay? You put all the probability on one side, okay? Here, just those two-tail test, okay? And the same trick we're using, right? Look at S1 square, S2 square, right? Something like this, okay? Somewhere, one is somewhere here, okay? And, but what we have is 1.5, okay? And then what you want is look at the two side, alpha over 2, here, alpha over 2, okay? And you want to check whether 1.5 is actually inside this region or outside this region, okay? And what this guy is 0.55. Do note that the slide you have as a typo should be 39, it's 4939, okay? There's typo over there, okay? And the number are changed, but this number, as I said, will be, later we'll show you in Excel again, will be F inverse, okay? 0.025, okay? You put 39 here, okay? And same here, you put 0.975, okay? That's give you these two number. And this is, since this 1.5 is between these two extreme value, so you cannot reject at 5%. Is that okay? So that is the last example. We have this, and then we expect to have a quiz on Thursday. Okay. Okay, so let me show you the Excel. Okay. So let's see. So here we have, let me erase to start again. Okay. So we have N is 50, N2 is 40. This is two tail, right? Because you use a 5%. Okay. So we need to use the critical value, right? So it will be inwards. Okay. And then you put probability, which is this guy. Degree of freedom will be this -1 and this -1. Okay. So then other rerun will be F inverse. Okay. This guy, again, we have -1, -1. Okay. So inverse. Okay. And or you can use the F inward, as I said, right tail, okay, of B3 -1 and -1. I think there's my keyboard one has always a problem. Sorry, not B3. It's A3. Okay, so they give you the same answer. Maybe I should do it here. Okay, so they're the same. Is there a question? If no, then we are going to show you the very last thing is the why this is chi-square. Okay, this is chi-square under the null hypothesis. Okay, but let's recall what we have is I think this is, I hope you still remember this S1 square is this guy, summing of all the number divided by N1, right? And the S2 will be summing all the number divided by N2 minus 1. This is a sample variance, okay? And you can divide and multiply, right? The same thing to cancel out. And you can divide and multiply, okay? Why we do that is because this, right? What we learn is this is chi-square n minus 1 degree, n1 minus 1, okay? And this is chi-square n2 minus 1, okay? And under the null, they're the same, so they can cancel out, okay? So what is left is chi-square n1 minus 1, okay? And this is chi-square n2 minus 2, and divided by n1 divided by degree of freedom, which is f, okay? And that's why this guy is f. So that is that's how we do. Okay, and finally, probably you ask why we care about they're the same variance or not. First, if they're not the same, so if you can prove they're the same, well, sorry, you can say you cannot prove they're different, then you can use the t-test of an equal variance, right? That's behind the idea why you can use equal variance, right? You can check if the data, use this to check they are the same variance or not. Once you're done, then you can go back to see which t-test you want to use, right? So that is that's why underlying why you can use the same or different. Okay, if they're different, you reject that it's different, then you have to use the unequal one. Okay, so that is the idea why behind. And also sometimes you care about the variance the same or not, right? You want to see whether the product, say you are the quality assurance, right? You want to check whether the same product or different product, the same variance or not, okay? So that's also the application. Okay, that's why you care about the variance. Is there any question? So this will be the part that you are going to have quiz on first day. If there's no further question, then we'll go over Excels on how what principle for what? You mean the F test? Oh, so the F test is, again, is why we're doing is, look, principle means the application or the proof? Oh, the proof, okay. Let's go to someone asked me the proof again, so let me go for the proof again. So you want to prove this guy equal to the F, okay? And F is saying that is f of n1 degree minus 1 and 2 is the chi-square n1 over is degree of freedom, and this is definition. So this is the meaning of f. Is that okay? For this one, just this definition. So we want to achieve this. How? Go to the beginning, okay? The standard deviation, sample standard deviation is this guy. Is that okay for this one? Okay? And this is this guy. I hope this is okay. Next, you divide this and you multiply this. You didn't change anything. Okay. And next is you also do the same for the denominator. Okay. Why we do that is, I don't know. I don't have color enough, but this guy we prove the summation this over this guy, right? It's a chi-square n minus 1. Okay, so that's why this is chi-square n1 minus 1. Okay, same as denominator is chi-square n2 minus 1. Okay, and under the null, they're the same, so they cancel out. And this is y chi-square n minus 1, this chi-square n2 minus 1. So that's the underlying why this is true. This is a proof. Okay, we prove it for you, so this is complete proof. Except, of course, we didn't prove this is true, but we didn't, this is outside the undergraduate level, at least outside the 2000 level, at least not in the B school. I don't think B school cover that. Okay, so what is left, we will go to Excel. Any more questions before we start Excel? So before we go to Excel, I will talk about several functions that we are going to cover in the remaining 15 minutes. So we will cover the following function. First, maybe I should use the red color. So we will cover this several things. We will cover the I think confidence norm and confidence. Sorry. Confidence norm and confidence T. This, what they give you is margin of error. Okay. Is this guy, right? Norm will be ME will be Z alpha over 2, sigma over root n. And this is Tn minus 1 alpha 2 S over root n. Okay. So these are the two first formula. We are going to talk about the two formula. Okay. And the next is hypothesis testing. We'll cover two things. One is z-test. Okay. This directly gives you p-value of two-tail test. Two-tail test. Okay. And with t-test, okay, the t-test is p-value of this is a two-tail test of one sample. Okay, if you give you two-tail test, two sample. Okay, so two sample actually means we have a three kind of style. One is an equal sigma, and also pair. Okay, so they are coming directly from data. So given the data, you can calculate the p-value of this. So these are, we are going to talk about that. So I will talk about the slide directly. I guess this is the slide I've uploaded. So let's talk about this estimation. So much complicated. I think this should be okay. I'll do that. No. Display setting, swap. Okay. We can see my, maybe it's not good to use this one. Let's see. So let me stop sharing. Just a second. I think I'll create PDF here. Because the Excel is always, just wait a second. So we will be talking about the estimation in the slide I gave you. So we cover estimation this part. So as I said, I will do the confidence norm and confidence T. Okay, so basically this gives you a set marginal error when you have a alpha confidence level. Okay, do note that you input alpha but not alpha over 2. Okay, so you don't need to trick your mind. So just put a 5% or not. Okay, so this is the what you're going to input in Excel. So I'm not going to work out. This is the same as you do Excel. So this is data, right? And this is given from the question, right? And you want to do 95%. Okay, usually given from a question. If nothing given, then this is what we do, right? And Excel will say, oh, this is the mean. Okay, coming from this, right? And n will be 6, just count of them, right? And here we can immediately invoke the confidence form norm, right? Because this is the function is the 3 input, right? You take the input of alpha, second input would be the sigma, and third input would be the n, okay? Right, because this is z alpha over 2, sigma over root n, okay? So that if you do this, that would be the formula you have, okay? Okay, so this give you this number, but alternatively, you can calculate this z alpha over 2, right? 1.96, right? It's norm as C2 over 2, okay? I guess it's not quite correct. I think you have to take 1 minus. Yes, you take 1 minus, sorry, this is 1 minus C2. Should be 1 minus C2 over 2, okay? And once you have this and you multiply this by, this is the Z, right? And this is sigma over root n, okay? This is over root n. So you get the same answer. This is how you do the marginal error for normal, okay? So this is shortcut. I don't know whether you like this shortcut. I don't really like that because it's not really useful at all. So, but if you like it, you can use it to save some time. But I don't think it's more clean. But if you like it, you can use it. And the other one is same, just t, right? T with same instead alpha, right? You get alpha instead of giving the sigma square, but you just give s square, okay? But so give s, not s square, just give s. The sample standard deviation and click n, okay? So you will see here the same trick, right? You have this, but now I don't give you the sigma square. We don't have that. We have to calculate ds directly, okay? So the mean, you can calculate that, right? And count how many of them, 6, okay? The SE, right, is the standard deviation, right? This is standard deviation divided by root n, okay? S is sorry, this is S, standard deviation, this is SD, standard deviation, SD. This is SD, that would be this. And the confidence, right? Confidence will be just input the number. Input the number is the alpha S and then N, right? So that is, you put the alpha, you put the S, and then you put the N, okay? And you also can do a T thing, right? This two tail is the same as T inward alpha over 2, okay? C3 minus 1, the same thing. This 2 times, you just give the alpha, same as 1 minus alpha. Okay. And that you can multiply, give you the margin of error. Okay, so this is the confidence T. Okay, this again, this gives you the margin of error. Okay, once you input all this number, then you're done. Now, if you don't have any question, then we go to hypothesis testing. So as I said, for one sample, you have T Z test, you don't have T. Okay, you don't have T. So we have to calculate like we do in the like we have done in the assignment. Sorry, in the slides. Okay. So compute directly, and the two sample tests. Okay, is for T for proportion. You can also use the C test, right? Directly, and for the T you have the T test and also the F test. So that is what we're going to cover today. But don't worry, you will not be you will not need it for your quiz, okay? But just you might be needing it for your homework, okay? If you want a shortcut, but otherwise the thing you cover in the class is already done, but just some further help from here. So here we have the function called C test, okay? This one will give you the one tail, right hand side one tail, okay? It's a right tail test, okay? The left tail, we have the 1 minus the result. Okay. So what we have here is a data, bunch of data here. Okay. And we use z-test. So this is this given is the given standard deviation. This mu is 4, saying that the null mu equal to 4. Okay. It's a right tail test. So it's mu is bigger than 4. Okay. And how many data here? Count how many of them? 6. Okay. The sample mean will be average of those. Okay. Now I want to test this. We can directly done the z-test. Okay. We don't need to calculate all this because we can feed the data, which is A2 from A7. Okay. So that's how you save your life. It's just directly input data. Okay. And then you only need to input I don't think it's C3. I think it's, yeah, it's C2, sorry. This will be C2. You input the mean is 4, okay? And at the end, you put the sigma, okay? You put in the sigma. Okay? Alternatively, okay, you can calculate it by looking at the mean, right, this mean, minus the mu, okay? Right, because it's x bar minus mu over sigma over root n, right? C4, C3, this is C1, and root of C3, okay? This gives you the Z, right? And the P value, right, will be, because it's right tail, so we just, now the 0 is 0.816, right? The P value will be on this side, okay? You take this and 1 minus, okay? So this is how we do the right tail, okay? Either you do this directly, right? Or you can check one by one. Okay? And the right tail, so the left tail will be just 1 minus because the left and right are just 1 minus, okay? And this is the same thing here, just 1 minus. And do note that the two tail, how to do two tail, is 2 times the minimum of the left tail and right tail. So here is take the minimum, this is a function minimum, left tail and the right tail. Why this is the case? It's very simple. Okay. This is 0 here. Okay. And either you're here Okay, if the rejection region is this side, right, you double it here, right? And on the other hand, if it is here, okay, you double it here, okay? Either you would take the minimum, right? You don't take the maximum, right? Either left or right. If you are the left, you take the left side. You're right on the right hand side, so make sure that you are the minimum. So that's why 2 times minimum of that. Okay, so this is the definition, the shortcut of the p-value of the two tail. Okay, and so this is two tail. I'm not going to, I think the same thing, but you just use the function to do 2 times of that. So give you the left tail and the right tail. So that is the idea. So if you do the t-test, as we said, there's no particular rule, fast rule. So you have to actually work it out as we do in the assignment. Okay. So there's no shortcut for that. And this left tail and right tail, we are not going to go over it because I think you know it enough. Okay. So the proportion is just C is Z. So there's nothing but the z-test. So there's nothing new here. Okay. The same thing here. Okay. Proportion, the same thing. Okay. And now I think with 2 sample. Okay. For 2 sample here, as I said, that would be, is much more simple. We can base on the data X and Y. Okay. And then you can tell me what tail you want. Is right tail or 2 tail? Okay. If left tail is just 1 minus. Okay. 1 minus the right tail. And the type is what we have covered. Pair, equal variance, and unequal variance. Okay. Don't worry. Almost time's up. So I just very briefly go over it, and then we'll talk about it again after the quiz. Okay. So so here, very briefly, suppose data is X here and data Y here. Okay. And what you want is the difference, right? And then you can calculate the number of them, the mean of this D column, the SE, and look at the T value, look at degree of freedom, look at the P value. Okay, it's a bunch of complicated object. Okay, and the other way around is look at the P value directly. Okay, you just t-test, give me the X column, give me the Y column, and this is pair. This is a right tail, and this is a pair. Okay, this is 2 tail. So this is right tail. Okay. And this is a paired observation. Okay. I just go through it quickly in case you're interested, but we'll talk about that more in next class. So if you have 2 data, you want to say equal variance, okay? It's complicated, right? You say, hey, how many A of them, how many Y, what's the difference between them? What is the pool the sample? You want to calculate the denominator, and it's the t distribution, and do all the way around, right? It's kind of complicated, but you can just input the data, t-test the X column, some first sample, second sample, right tail test. This is the equal variance with the 2. Okay, you can skip so many steps. And similar, you have the same thing for the unequal variance. Okay, unequal variance. You do the same, but you have 3. Okay, but I just give you the brief view. We'll go over the Excel again after the quiz next class. But you don't need to use Excel for the quiz because it will be similar to what you seen in the slides. This function will cover it again. Okay. let's end for today. We will talk about this. We will see you Thursday, and then with the quiz, and then we go over again for the Excel. Okay. Bye bye. Thank you.
Hello Professor，我有啲嘢想問。
Yes.
我想問可唔可以去一去 random variable 嗰一課？
OK。等一等啊 ，random variable。OK。
page 59，第59個 slide。
係咪大概呢度？有啲同你可能有啲唔同，係咪呢度？
唔係，係transformation 嘅 example。
睇下先，係 normal 㗎係嘛？
係。
呢個係嘛？
再落一頁。
OK。
呢度我想問下咧，即係上邊嗰度啦，佢話 x is greater than 24，咁佢係 set 大過1，咁佢 Excel gen 出嚟個數係 x 係 set 細過1，所以要1減，係咪咁樣？
冇錯，因為 Excel 個係左手邊。
咁跟住下邊咧，佢16細過 x 細過24啦，咁都係-1細過 set 細過1咁樣，所以-1要1減。
因為對稱嘅呢個，因為呢個係呢度係呢個細過1減以呢個細過-1，拆咗細過-1。咁但係佢對稱㗎嘛？呢個1，呢個-1。喂？
係唔係因為咧
你可以直接入-1嘅，你可以直接呢個可以直接揾到出嚟。
係就係我呢個直接入-1嘅時候
，1587冇問題。
佢就直接即係 Excel 就直接 gen 咗個。
你可以呢個你可以直接入norm.s this -1。
咁我點知我幾時係要1減，幾時係唔需要1減？
左邊咪1減咯，你嘅計左邊就唔使1減咯，你計右邊咪1減。因為個 this 係就係計左邊啫嘛。
但係佢呢一個佢 Excel 直接 gen 出嚟嗰個數，咁就唔使1減咯。
咁呢個我用 symmetric 我費事做嘅，你可以直接寫0.1。如果你覺得 confusing 嘅，你可以直接寫0.158都得嘅。即
係如果1同-1呢兩個係一模一樣，只不過正
1同個-1啱啱對稱㗎嘛。
所以就唔需要1減。
因為你呢個係呢個0.85幾啊嘛，0.84，咁你依邊咪減翻咪1.587咯，咁咪對翻正呢邊同呢邊一樣咯。
咁即係話如果嗰個-1，譬如可能如果佢係-2嘅話，就唔可以咁樣，咁就 Excel gen 出嚟個數就要1減咁樣。如果佢唔係對稱。
係啊，咁你直接如果呢個係-2，譬如話呢個係2，咁你咪直接入-2咯。
咁如果呢個我直接入-2嘅話，Excel gen 出嚟個數需唔需要1減？
需要1減㗎。
都唔需要。
1減啊，只係做咗，你直接入0.158得啦。如果覺得混亂嗰陣時。
唔係，因為我就係唔明點解咧呢一度咧，佢明明都係 set 大過負嗰個數啦，咁但係呢度唔需要1減，但係上面就要1減，我唔明。
因為上面大啊嘛，因為你右手邊。
咁但係佢而家呢度都係 set 大過-1㗎。
因為1同-1係一樣㗎嘛，同呢個一樣㗎，呢兩個一樣㗎，因為對稱㗎嘛。但係如果同呢個因為0，因為佢一個鏡面嘅問題，呢個同呢個一樣啊嘛。
咁即係咁，但係如果下邊嗰個係-2細過 set， 再細過一嘅話，咁一同負二唔一樣，咁係咪即係話要一減？如果佢哋兩個唔係對稱嘅話？
我唔係好明。
即係而家係因為一同負一係對稱，所以佢先唔需要一。
因為我唔使揾兩次嘛，揾咗我就唔使揾兩次咯，簡單啲啫。
但係如果前面嗰個係負二啦，後邊嗰個係一，咁佢兩個數唔對稱，咁係咪真係負二？set 大過負
如果你係二，你係負二係嘛？
係即係前面係負二，後邊照翻係一嘅話，咁佢哋兩個唔對。
咁你揾一，咁你咪要揾負二咯，咁咪負二咯。
咁負二 generate 咗出嚟個數之後，使唔使一減？
梗唔使啊，
但係佢而家係唔對稱喎，一同負二。
唔係咁樣減，呢個係揾緊咩問題咧？我哋可能唔係好明白。你呢個問題係
唔係，因為即係上面係要一減，但係下邊就唔使一減。我係唔明呢一個位。
因為點解減？因為你個 Excel 就係比你細過佢啊嘛。呢個係點解減咧？呢個係咁噶嘛。呢個 Excel 直接揾到 Excel 就係俾呢個嘢嘅。
我明呢一度，但係我唔明點解就係呢一度個 set 大過一要一減啦，即係佢 generate 出嚟個數係大過一，你就要一減，但係下邊 set 大過負一個數
呢個
就
係呢個係呢個係呢個嚟嘅。細過負一，但係細過負一即係話都等於其實佢大過一噶嘛。
嗯。
咁即係呢度咯。
但係我入 Excel 嘅時候，佢 generate 出嚟個數上邊咧係要一減，即係佢上面 generate 出嚟係0.8413嘅。但係如果我入負一嘅時候咧，佢就直接出咗零。
梗係啦，你直接負一係得㗎。我先咪講咗一次，可以直接負一㗎嘛。你而家問呢個係直接負一㗎咩？呢個係負一嚟㗎嘛？細個嗰個細個呢個 distribution function 嘛，你可以直接負一㗎。負一咪出呢個咯，一樣㗎嘛。大細呢個大過一同細過負一係同一嚿嘢嚟㗎嘛。頭先我畫幅圖俾你睇啦，呢個零，呢個一，呢度負一，大過一同細過負一係同一樣㗎嘛。
好，唔該晒。
Okay. Any more question? Okay, then I will end this. There's no more question.